Number one, what are the four states of matter? They are solids, liquids, gases, and plasma. Plasma is the one you might not be familiar with. If you don't know what a plasma is, it's a superheated and ionized gas. And you might be saying, well, isn't that just a gas? And the answer is, like, kind of. Okay? If you're wondering what the difference is, here's the difference. Okay? There is gas inside of this tube. Okay? When I turn it on, it ionizes the gas and turns it into a higher energy superheated gas. That's what you see is the little electricity bolts, the lightning going on in there. So that is plasma. So plasma is superheated, ionized gas particles, which is why your book does not talk about plasmas at all, because plasmas are essentially gases that are special. Yeah.
So what's a colloid?
Oh, colloid is where you have two states of matter that exist simultaneously, but they exist one inside the other. So like a marshmallow is a colloid because it's a solid, but there's a lot of gas bubbles inside of the marshmallow. So that's a colloid. Colloids are like my favorite. They're so weird, and yet they're awesome. So yeah, colloids are two states of things that exist simultaneously, or like a carbonated beverage. Like it's got gas inside of the water molecules, so it's a liquid and a gas. Okay? All right, there's number one. Number two, upon what two things does state of matter depend? Temperature and pressure. Temperature and pressure. So, it is not just temperature that causes phase changes. It's also pressure too. However, we don't usually think about it in that term. We usually just think about it in terms of temperature. And that is usually what the factor is. But we'll do some examples here. And then tomorrow we're going to watch a bunch of like video clips. And some of the video clips will talk about like doing pressure as a way to change the state, as opposed to doing temperature. Okay? So pressure and temperature are the two things. All right, what's evaporation and how does it work? Braden, tell me what evaporation is. Tell me how it works.
It is the change of phase from liquid to gas that occurs with dispersion of liquid.
Okay, so it's the change of phase from liquids to gas. And he mentioned it takes place on the surface of the liquid. So at the barrier between liquid and gas, that's where this happens. The the water molecules turn into gas molecules. Okay, so that's evaporation. And how's it work?
It works when molecules at the surface collide and bounce off and evaporate.
Yeah. So molecules in the water, well, we'll see in the liquid, gain energy, usually through collisions. And become gases. Okay, so particles that are inside the liquid gain energy through a bunch of different ways. They could hit other liquid particles. They could get hit by a gas particle. They could already be at a higher temperature. There's lots of ways, but basically they get enough energy that they turn into a gas, because a gas is at a higher energy level. Okay, so they turn into and become gases. All right. Nathan, how does sweating keep our bodies cool?
Energy is transferred out of your skin, and you're left with sweat on your skin.
Yep. And then evaporation happens from there. The higher energy particles that are in the sweat go into a gas, and you're left with lower energy particles. So heat transfers from you into your sweat. And those particles evaporate and cool you. See, evaporation is a cooling process. What are you left over after the high energy stuff leaves? You're left with low energy stuff, and lower energy stuff will cool you because the heat's being pulled out of your body. So the heat's being pulled out of your body, putting into the sweat, and then evaporating from there. Now, why is it that on really humid days it feels really hot? Well, on really humid days, your body doesn't evaporate the liquid because on 100% humidity, the air is saturated with water. So there's no more room for water molecules to leave the sweat and go into the atmosphere. So they just stay on your body full of all that high energy and feel awful. Okay, that's why on really humid days it feels so muggy and gross. It's because the particles can't evaporate. Okay, and so they just stay on your body and you're like, ugh. That's why you go someplace like Texas or Arizona where there's not very much humidity. You'll still sweat and feel hot, but it won't feel as muggy. It won't feel as bad, and so people call it a dry heat. It's a lot more manageable for some people. All right, Logan, tell me what sublimation is.
It's a solid to a gas.
So sublimation is a solid to a gas. Okay, so it's a solid to a gas. And it's basically the same process as evaporation. Higher energy particles leave the solid and turn into a gas. But they have to be really high energy to do it. Okay? You've all seen this before. What happens if you leave ice cubes in the freezer for forever? They get smaller and smaller and smaller and smaller and smaller and smaller and disappear. Okay? And you're saying to yourself, well, where's the liquid? They didn't melt. No, they didn't melt. They did this. They did sublimation. Some of the molecules get high enough energy that they leave and turn into a gas, and then they stay in your freezer. Okay? And eventually they turn back into a solid again, and that's why your freezers have to be defrosted every now and then. Okay? So we'll talk about that in a little bit, though. So sublimation and evaporation are the same idea, except sublimation is a solid to a gas. Okay? Excellent. Group 2, condensation. Sawyer, tell me how condensation works.
It's when a gas changes out of a liquid, high energy particles hit, from the gas hit the lower energy ones in the liquid, and they kind of join it and push other ones out.
Yeah. So higher energy gas particles lose some energy and become liquids. Okay, so they lose some energy and they become liquids. So it's the opposite, right? Instead of gaining energy and becoming a gas, they lose energy and become a liquid. Okay, so they're giving their energy up into the liquid. They're giving their energy up into the liquid, or whatever the case may be. Whereas this one, they're losing their energy from the liquid and becoming a gas. This one, they're giving their energy up and becoming a liquid. Okay? So that's condensation. All right. So why do water droplets form on the outside of the glass? Gabe, what do you got for that one?
Gas particles lose energy when they hit the outside of the glass.
Yeah, so they hit the outside of the glass, they lose energy, and they turn into a liquid. And that forms little water droplets on the outside of your water. So what's happening? It's turning into a liquid because it's losing its energy. Well, where is it losing its energy to? To the colder thing. So the colder thing warms up. So how is this a warming process? The higher energy particles go into the colder energy substance, and the colder energy substance gains energy and becomes warmer. So the lost energy goes into the colder substance and causes warming. All right. On to the book. Making